evening, everyone. First of all, I would like to thank organizers for giving me the opportunity to be here and present this very important data about vitamin K2 and bone health. So, because we had a very nice introduction of the mechanism of action by previous speaker, I won't go into details, but I would like to remind you only that vitamin K can go into recycle in the body. That's why we don't need a huge dosages for supplementation, and the microgram dosage is efficient to support healthy bones and healthy cardiovascular system. What about the field of action? As previous speaker said, we've got many of them, but these which are the best study are homeostasis, bone health, and we've got a lot of clinical studies published recently which show that vitamin K2 is crucial for healthy cardiovascular system. So what kind of vitamins do we have? It's a family of vitamins. We've got vitamin K1, and vitamin K1 cannot be synthesized by humans. Vitamin K1 is an origin from plant, and it's tightly bound to chloroplasts. That's why it's very difficult to get vitamin K1 from your healthy green diet. It was shown, as Dr. Schurger said, that only 10 up to 20% of vitamin K2 from green vegetables is absorbed and can reach circulation. However, vitamin K2 is very, very well absorbed and can reach extrahepatic tissues, so can support other field of action than homeostasis, can support bone and cardiovascular function. And what the source of vitamin K2? Vitamin K2 is synthesized by bacteria. It can be synthesized in our body, and it can be found in some products. This slide was shown already, but I would like to remind you because it's very important in my opinion. I receive a lot of questions through vitamink2.org, and people ask, they don't want to supplement. They are interested to change the diet habits. However, it's very easy in some cases. It's not so easy for vitamin K2. As you can see, the richest source of vitamin vitamin K2 is fermented natto, so fermented soy. However, it's not popular in Europe as well as in US. You can find some decent amount of vitamin K2 in cheese, but I will talk about it more on the next slide. Regarding K1, I showed before that the richest source, of course, are green veggies, like a spinach, for example, or broccoli, but we've got a problem with absorption. So regarding the cheese, Dr. Goodman said before that he, as a cardiologist, won't be happy to patients to have a lot of cheese every single day, but I would like to point that we've got the different cheeses on the market, and probably the only good cheese can Dr. Schurger find in Maastricht, because this cheese, old traditional cheese, contain a lot of vitamin K2. Not a lot, but decent amount of vitamin K2. However, when samples from Gouda cheese from US were tested in Vitak Institute, they found that there is zero vitamin K2 in this cheese. So if you are mom and you are crazy about your healthy bones for your children and you give them cheese macaroni, you should know about it that you don't give them vitamin K2, so you don't support them healthy bone. So I told you about it that we've got a problem with the intake of vitamin K2 in a regular food, but what about the deficiency? How can we recognize that we are deficient and we need vitamin K? So everyone knows that if you have a problem with bleeding, so it's familiar for majority of people, and it's known for the doctors also, so that you don't have enough vitamin K. So people are supplemented with vitamin K1 in this case. However, we've got a second model. We've got a second situation, which is called chronic deficiency. Otherwise, we can say subdeficiency. So we don't bleed. Our coagulation system is perfectly fine. We feel okay. We don't feel any pain in the bones. Our arteries seems to be okay. However, our extrahepatic proteins, which are important for bones and important for cardiovascular system, are inactive. It means that they cannot act properly, and calcium cannot be removed from the arteries and put in the bones. In this stage, if it takes a long time, in this case of the subclinical deficiency, it will lead to osteoporosis and vascular calcification, as well as other age-related diseases. So if we look at this graph, it represents different intake using different diets. So very often, children are on a junk food. Even if mom takes care of them, they prefer to have hamburgers and a fast food. So you can see on this graph that they don't have at all vitamin K1 and vitamin K2. However, many people are crazy about the healthy living. They exercise a lot, they eat a lot of green stuff, and they think that they can help their bones to be healthy. And of course, the intake of vitamin K2 in this population is pretty high. But I told you before that we've got a problem with absorption. So even if the content of K1 is big in a salad, the amount which reaches circulation is pretty low. The only healthy people, not healthy people, but happy people are in Japan because they eat natto every day, and the intake of vitamin K2 is pretty good in this population. So the major source of vitamin K in Europe, and probably the same in US, vitamin K1 is the major source of this. So one issue is the intake of vitamin K. It changes, depends on the diet. But it's nice to see if we can check deficiency in the blood. And we've got some commercial assays which are not popular right now. It's at the research stage, and they are used in clinical trials when scientists evaluate vitamin K-dependent proteins which are inactive. And it represents vitamin K status. And on this graph, you can see two of them, dephosphorylated uncarboxylated MGP, which represents a very important cardiovascular marker, and undercarboxylated osteocalcin, and both of them are found up to 30% in Western population. So it has been shown by the Maastricht group that people in Western Europe are deficient. Moreover, in 2011, it was published study that around 97% of the population is K deficient. The study enrolled more than 450 volunteers, and the volunteers were evaluated for the amount of inactive MGP. And 97% of them had very high level of inactive MGP. So can we do something about it? Yes, we can do using a supplementation, and in this study, vitamin K1 was used for supplementation over 3 years. They used 500 microgram daily of phylloquinone, and they found out that in this group, which was supplemented with vitamin K2, the level of inactive MGP dropped dramatically. So I was talking a lot about the healthy volunteers and healthy adults, but my talk should be focused on children. So what we know about the children? So only 2 different studies were published on children when they found out that children have very, very high level of inactive osteocalcin, which is very important bone marker. If you look at this graph, you can see the first bar represents children below 10 years of age, and the second bar represents children between 10 and 19. The bars are huge in comparison to the smaller bars, which are for adults. So children showed in the study the largest specific vitamin deficiency, and it means that children should benefit the most from vitamin K2 supplementation. So, because the previous talks were about mainly cardiovascular system, I would like to say more about osteocalcin. I said before that we've got 2 forms. One is inactive and the second is active, but it's very important to remember that only active form can bind calcium and support healthy bones, and this can be evaluated. So vitamin K2 is not the only vitamin which is necessary for healthy children's bones. We've got a second one, very important vitamin, and everyone knows about it. So it's vitamin D. Vitamin D is involved in bone mineral metabolism and bone growth. It can have many different functions. The most important are that vitamin D increases calcium absorption, and we need a calcium for healthy bones in children to grow stronger. Moreover, vitamin D stimulates synthesis of osteocalcin and promotes bone formation and mineralization. So we know that vitamin D is important. We need a second factor, which is calcium. And a lot of food in the US is fortified with calcium, actually. And Dr. Kudman told us today that it may be also dangerous for adults. But in the case of children, we know that calcium is not enough. The recent study evaluated the intake of calcium in developed countries such as US, New Zealand, and others, and they found out that children have very high intake of calcium every single day. The intake may be even up to 1 milligram per day, 1,000 milligram per day. However, the rate of fracture is still high in these countries. So if I would like to convince you that for a healthy bone, we need not only calcium, we need also vitamin D, and we need a vitamin 2, which can be a friend of both of them. So why it's like that? So active form of vitamin D influence our intake from the intestine, increases intake of calcium from the intestines, so we've got in a blood. But we would like to put this calcium from the blood into bone to build healthy bones. Moreover, active form of vitamin D increases the synthesis of osteocalcin. So we've got this very important protein which is necessary for healthy bone. However, I showed you on a previous slide that osteocalcin can be shown in two different forms, and we need active carboxylated form of osteocalcin. And in this case, we need vitamin K, and the best vitamin K2, because it was shown that vitamin K2 is more efficient than vitamin K1, and MK7 seems to be the best solution for this. So when we've got osteocalcin, which is carboxylated already, in this case, calcium can bind to this, and it can be bound to hydroxyapatite and to support healthy bones in children. So to have a right and good vitamin K status in children is very important, because you need to build a strong bone when you are young, when you are a child. If you can build your high strong bone before you are 30, it means you've got the strong bones, you've got a lot of bone tissue to lose when you are old, and your risk of osteoporosis is much lower than if you have a really bad diet and you are deficient in vitamin K2 and vitamin D in your childhood. Moreover, I showed you that young bone tissue is very active. Only osteocalcin levels are up to 10 times higher as compared to adults. That's why vitamin K requirements are also higher for children than for adults. And very often vitamin K2 is used only for osteoporosis, and nobody remembers that children are very important and we need to take care of their bones too. So I told you that we've got a problem with the intake, but we also need to remember that we change our food habits over the time. And there are many studies published actually in Europe which showed that the consumption of vitamin K decreased gradually since 1950 in both genders, in girls and in boys. So we know that the children eat less vitamin K2 than it used to be, but does it correlate with the bone health? And I think this graph is very convincing because it showed that over time there is an increased rate of the fractures in the children. And it was confirmed by many scientists in different countries. It was done in Europe, in Scandinavia, as well in the US, that there is increased number of fractures in different places in children of both genders. We've got many studies which prove that vitamin K status is very important for healthy bones in children. The studies were published from 2004 until now, and they proved that in vitamin K status can be associated with higher bone mass and less, that vitamin K status was associated with higher bone mass and a lower level of inactive osteocalcin. So the improvement in vitamin K status over time is related to lower bone turnover and subsequently additional increase in bone mineral content. There are two studies which I would like to mention at the end of my presentation. Both of them were done in collaboration, were done by NATO Pharma to some extent. MENA-Q7 was provided for the study. The first one is VITAC study, which was done and published in 2009 by Samaran Group. It was randomized placebo-controlled double-blind study which enrolled 60 children, both genders, the same equal numbers. The children were supplemented with 45 macrograms, so it's very, very low dose of vitamin K2 for 8 weeks. At the end and at the beginning, the children were, the blood was drawn and the level of undercarboxylated and carboxylated osteocalcin was measured. So the evaluation I will show on a graph which is represented by UCR, which is ratio of undercarboxylated osteocalcin and carboxylated osteocalcin, and it's really good marker of vitamin K status. So when the scientists collected the results, they found no changes in a group, in a placebo group, which was expected. However, in a group which was treated with MENA-Q7, it was decreased in UCR significantly. And it was found even after 8 weeks of supplementation with such a low dose. So it's nice to show that the biomarkers are changed by vitamin K2 supplementation, but do we have any proof that vitamin K supplementation can really improve bone in children's health? So far, we've got only one pilot study done by a Turkish group. The study was done on 20 children, 12 girls and 8 boys. The children had thalassemic osteopathy, and they were supplemented over 1 year with vitamin K2 and vitamin D3. During different time points at the baseline, after 6 months and after 1 year, the blood was collected, the level of undercarboxylated osteocalcin was evaluated, and measurements for bone mineral density was taken. So what's the most important, after 6 months and after 1 year, the results detected a significant improvement in bone mineral density and Z-score at the lumbar spine of these patients. So it's really nice data, because we don't have many data on a clinical trial on a children. It's very difficult to convince doctor to switch to vitamin K2, at least in Poland. So do we have any other diseases which can, when children can benefit from vitamin K supplementation? And my opinion is yes. I think that the children with malabsorption of fat and fat-soluble vitamins should benefit a lot. In the same case, children with cystic fibrosis, they've got a very weak bones. Very often they supplemented with K1. However, I think that vitamin K2 will be much beneficial for those children. So at the end, I would like to conclude that children showed the largest specific vitamin K deficiency, that MK7 is able to improve vitamin K status. It was shown by UCR, so activation of osteocalcin. Moreover, I will ask about the dosage. So the effective dosage which was used in healthy children was only 45 micrograms of MENA-Q7. In the case of the children with thalassemic osteopathy, it was 50 micrograms per children. And in this study with thalassemic osteopathy, MK7 improved bone mineral density in these children. And the last point, which is really important, that vitamin K2 is safe. for children, and it was proved not only in clinical studies in children but also in adults. Thank you for your attention.